In this case, you can see. Okay, so in this case you can see the positive terminal is also always known as south pole, and the negative terminal is also always known as north pole. Don't forget south and north pole. So how electricity will conduct? The electricity will conduct from south to north. Remember this. The electricity will conduct from south to north while these coils. Okay, you can see the electricity will conduct by these coils from south pole to north pole. Anyhow, the electricity will conduct in same manner. So in this case, this is our solenoid and this is our positive pole. So this is our south pole and this is our north pole. Okay, so electricity will conduct from south to north. Okay, it will conduct by these coils from south to north pole. So electricity is conducting from south to north pole. Okay, so this is our solenoid, and we converted our, we converted our iron copper into this solenoid. Okay, and definitely they are made up of these coils. Remember one thing, that you can use any amount of coil, 10, 15, 20. Okay, but the radius of this coil, this is the radius of coil. Okay, radius of this coil should not more than the distance. Okay, so there are two coils, so the radius of the coil should not more than the distance. Okay, distance should be lesser, very lesser. Okay, so these are the radius. Okay, so remember that radius should not be exceed than distance. Okay, now, oh sorry, I forgot, distance should not increase, distance should be always lower, and radius should be in much higher amount. That means if you are using something of radius, you can use any amount of radius. You can use 10 meter, 10 centimeter, 10 millimeter, or you can use anything. So if you are using 10 centimeter of radius, then the distance should be less than 10 centimeter. What do I mean? That if you are using here, there are thousands of coils. Okay, so if it is using 5 centimeter, one coil, radius of one coil is 5 centimeter, radius of one coil is 5 centimeter. Okay, then the distance should not exceed than 5 centimeters. So that, remember this thing. Okay, now this is south pole and this is north pole. So this will react there as magnet. It will react as magnet. Okay, why this will react as magnet? Because this is copper wire, this is copper wire. Okay, and we are providing electricity to this, current to this. So we know that metal plus electricity, metal plus electricity is known as electromagnet. Okay, so this is now electromagnet. This is south and this is north pole. So this will also work as magnet. So this is magnet now. Okay, this is magnet now, this is magnet. Okay, now it will work same as these normal magnet. So what happened, we studied that how magnetic field lines flow in these magnet. They will flow north, they will move north to south from outside. Okay, they will move north to south outside and south to north inside, if I want to complete this. Okay, so now this is also magnet, because we made this, we provided electricity to this coil, copper coil, and now it is converted to magnet. So now this solenoid is also magnet. This is a magnet now. Okay, this is a magnet now, this is a magnet now, this is a magnet now, don't forget. Okay, and remember that radius should be more. Okay, the radius, what is radius? This is the radius, should be more, and distance should be less. Okay, otherwise it cannot be considered as proper solenoid, or it will not work properly. So now this is magnet, and in this magnet I draw the magnet. Okay, so you can see it will develop as a magnet, and you can see the, or how electricity will form. Electricity will form from south to north. Okay, so some magnetic field lines develop. You can see some magnetic field lines. If I want to complete them, this is the magnetic field lines. So these magnetic field lines flow from south to north inside, though electricity and magnetic field lines. Okay, both of them will flow from south to north inside. You can see south pole, this is north pole, so both of them will flow south to north inside, and they will flow north to south outside. So there are some magnetic field lines which are developed as these magnet. So it will work as these magnet because it is converted to electromagnet. Okay, so we can consider that this is our south pole, this is north pole. So you can see that this current, okay, current and magnetic field lines will flow from south to north inside this solenoid, and north to south outside. Okay, current will not flow north to outside, just magnetic field lines are there. Current will always remain, or current will stay just in this area. Okay, current will stay in this, just in this area. Okay, in these copper wires. Okay, so the magnetic field, you can see this magnetic field, and this magnetic field is same in this magnetic field. Okay, these are magnetic field lines. So these magnetic field lines which are present inside the solenoid, remember everything, either it is current or either it is magnetic field lines. If they are passing from south to north, definitely it is something which is inside. Okay, so it have to pass here and it have to complete its circuit. So the magnetic field lines which are present in proper solenoid, this proper solenoid, okay, definitely they will produce some magnetic field lines. They will produce some magnetic field lines like this. This is real solenoid, it will produce magnetic field lines like this. Okay, definitely it will produce magnetic field lines, but the question arises that the proper solenoid, the area which is proper solenoid, okay, this is the area which is proper solenoid, okay, it is also having this magnetic field line. You can see these magnetic field lines, but the amount of magnetic field lines, okay, the amount of magnetic field lines in this proper solenoid, amount of magnetic field lines in proper solenoid is same. Okay, what is proper solenoid? Proper solenoid is only the area which is having these coils, and the amount of magnetic field lines, you can see the intensity of magnetic field line, the amount of magnetic field lines in this area is always same. So if you put a compass, or if you use a magnet, or anything you are using, you can easily see that the amount of magnetic field lines in this area is same, and it will change if the if you go apart from these original copper wire. Okay, so the area which is having copper wire, okay, this area, okay, particular this area, so all the magnetic field line which are present in this particular area are having same intensity or same power, or they are having same power, okay, to a solenoid. Okay, and second thing, that the solenoid will follow the rule of magnet, that how the magnetic field lines grow south to north inside and north to south outside. And what I told you, that positive terminal is south and negative terminal is north. So this is how our solenoid works. Okay, this is solenoid. Now in this solenoid, okay, this was our solenoid and it is made up of copper. You can see this is solenoid, okay, and the coils are made up of copper. These are the coils and they are made up of copper. Okay, so you can also, okay, so they are electromagnet. Okay, now if you want to, these are showing magnetic effect, they are magnet now. Okay, Now if you want to magnetize another metal, first metal is our copper and it is an electromagnet. Okay, and current is passing through this. Okay, this is our copper metal. Okay, now if you want to magnetize something else, if you want to magnetize another metal, copper is already copper is already a magnet. Copper is a magnet. Okay, now it is magnet because we have provided current. Now if you want to magnetize, or if you want to give magnetic effect to another material, just insert this, as this iron is inserted. Okay, so just insert another metal. You can insert any type of metal, you can insert any type of metal into this. Okay, this is inserted, you can see this is copper is iron is inserted. Okay, so copper is a magnet itself, and if you want to magnetize, okay, if you want to magnetize, or if you want to transfer its magnetic effect to another metal, okay, you can use soft iron, or you can use stainless steel. Okay, so you can use any metal. Okay, and insert this, and it will also get magnetized. So this is diagram of our book. This is diagram from our book. Okay, so in this coil, okay, in this coil you can insert any another metal. You can insert any another metal. You can see these are copper coils. These are copper coils. This was our solenoid, and you can see a soft iron rod is inserted. So you can magnetize. What is the meaning of magnetize? You are transferring the effect of magnet. Okay, you are just transferring the effect of magnet. So we are transferring the effect of magnet. We are transferring effect of this copper, which is magnet now, so we are transferring the effect of magnet. Okay, and magnetizing soft iron or steel, or you can use anything. Okay, so why we are doing this? We are just increasing the efficiency. What we are doing, we are increasing efficiency. Okay, we are increasing efficiency, we are increasing power of the solenoid. We are just increasing the power of solenoid by doing this. Just insert any type of, you can insert any type of you can insert any type of rod or another type of steel metal. Okay, so this is how we can increase the efficiency. Okay, now we have a question, and this is very simple question. We will complete this. So first question is, consider a circular loop of wire, okay, which is laying in plane of table, and less current pass through it. Okay, so this is our loop. Okay, this is my loop, and the current is passing clockwise. How clockwise? How works? Clock works like this. So this is the direction. Okay, this is positive and this is negative. Okay, only this is the case in which the current will flow like this. So I'm using my right hand rule, and you should also use your right hand thumb rule to find the direction of magnetic field lines. Okay, I gave you this question, just use this. Okay, and I did this. Use your right hand to find the direction of magnetic current, magnetic field lines, and I'm getting a current like this. I'm getting a direction of current like this. Okay, because it says this is clockwise in direction. Okay, it says it is clockwise. Okay, so this is clockwise and this is anti-clockwise. Okay, so this is, you can draw. Okay, second question is, the magnetic field in a given region is uniform. Okay, magnetic field in given region is uniform. We know that the magnetic field is uniform in given region is only solenoid. This is the region which is made up of coil, or the region which is made up of coil, or if you have inserted any type of metal in this coil, if you inserted any type of metal. Okay, you can insert any type of metal, but generally soft iron is used, so you can use. So the amount of magnetic field lines is same in this given region. The amount of magnetic field lines, or the intensity or the power of magnetic field lines, power of magnetic field lines is constant, or we can say same in this region. So this is our question asking. Our question is asking that the magnetic field line in given region is uniform. We have to draw a diagram. So this is the diagram, and in this diagram, the amount of magnetic field lines are equal. Okay, the amount of magnetic field lines are equal, and you can also see that amount of magnetic field lines are equal. In this case, they are changing, the amount is changing when they are passing the area. The amount is changing, you can see the amount is changing when the amount is changing at till this side. Okay, this side you can see the amount is same, the amount is changing, or the lines are deviating when they are crossing the area, but this region have same amount of magnetic field lines. So just you have to draw the magnetic field lines. Okay, and they will change their amount or change their direction when they cross this area, but in this area they are having same amount. Next question is very simple. Okay, magnetic field line inside a long straight solenoid carrying conductor. Magnetic field lines in these are, you can write me the correct option. Write me the correct option. I'm giving you 1 minute. The question asks you that the magnetic field lines in this particular region, okay, inside the solenoid, is zero. As decreases we move towards this, and either we go to this side or either we go to this side, it will get zero, or it will decrease, or it will increase. Either we go to this side or either we go to this side, it will increase. Okay, so it is starting from here, so we will consider this side, that if you go this side it will get zero, or it will get decrease, or it will get increase, or same at all the points. What is the correct answer? Yes, Saleh gave me correct answer. Hasan, what about you? And this solenoid, definitely they are having magnetic field lines. We study about these magnetic field lines. Okay, so the question is asking that magnetic field lines are zero in this solenoid, or if we go from one point to another point it will decrease, or if it will decrease if we go one from point to another point, or if it will increase if we go one point to another point, or they are same all along the length of this solenoid. Azan, what is your answer? They are same. Okay, why they are same? We studied this thing now. We studied this thing that same, they will be same, they will remain same. We studied this. Okay, that you can see this only this portion, in this portion you can see only in this portion they are same. Okay, they are deflecting, or they are changing their path, or they are doing anything, but after 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 they are coming out from this region, but at this region you can see these magnetic field lines are same, they are same. Okay, so this is our question. We studied this. Okay, now I have to start second topic, but only 1 minute is left, so I will start this topic in next class. If you have any problem regarding to today's class, you can ask me. Okay. Okay, let me ask you one question and I will give you only 30 seconds. Okay, why this pole is converted to negative, and why this pole is converted to, no, sorry, why this pole is converted to north, and why this pole is converted to south? Why this pole is converted to north and why this is converted to south automatically? Can you answer me? They will convert automatically by the rotation of these field lines. As the field lines, yeah, very good, Faizan, very good. Okay, because they are changing their, how the field lines are changing their path. Okay, yeah, direction of current. Okay, so they are predetermined and they can determine their poles by their own. Okay, on their own. They don't need us to determine poles. They will determine their own poles by the rotation of or by the direction of magnetic field. Okay, so today I'm finishing my class, and on next class we will study about these rules. Okay, and this is the thumb rule or left hand rules. Okay, so I'm finishing my class.